Alright, so in this session we're gonna cover JavaFX, which is a very small topic. Uh, so before we jump into new controls, let's discuss some rules for JavaFX because these apply to everything we build this week and in future. So first, what is JavaFX and why use it? Think of it as a modern scene graph UI toolkit. So instead of old school swing widgets, a JavaFX builds a tree of nodes, labels, buttons, panes, shapes. Each one is a node in that tree. It's hardware accelerated, no animations and effects are smoother. It supports CSS styling, which means you can theme an app like a web page. So now the app skeleton, which is every JavaFX app starts the same way. You extend application, the runtime calls start, which is a primary stage. Inside start, you create your UI, put it in a scene, set the scene on the stage, and call show. If you remember nothing else, remember stage is equal to window, scene equals root container, node is everything you put on the screen. So next, the scene graph structure. Picture a tree. At the root is the layout pane, say a border pane or a VBox. Inside that you place other panes and controls, and layout panes like HBox, VBox, GridPane, border pane manage size and rotation for you. You don't hand place pixels. You compose containers. This keeps UIs responsive when the window resizes. So the JavaFX application thread, FX thread, all UI work, creating nodes, changing text, updating controls must happen on the FX thread. If you do heavy work like file input output, network calls, big computations on that thread, the UI will freeze. So do heavy work off thread using task or service. When you need to update the UI background code, call the platform.run later, or use task properties like message property to flow results back safely. So fast on the FX thread, heavy of the FX thread. When it comes to styling, JavaFX uses CSS. You can set quick inline styles like FX padding 10, or attach a full external style sheet on the scene. This is a big win over swings, look and feel fonts, colors, spacing, hover states, all in CSS. We'll keep styles simple, but now that polished UI comes from a little CSS. An example is you can like a VBox with 10 pixel spacing. You drop in a label like hello Java FX, and a button called click me. On click, it updates the label text. That's a one line lambda handler on the FX thread, and you add a touch of CSS like padding on the VBox, a larger font for the label. That will be a complete clean starter. You can paste it in your IDE in under a minute. So we have JavaFX versus Swing, which is a scene graph, CSS, hardware accelerated. We have skeleton application. You start with start, that's a stage. You build nodes, then scene, and then show. uh, Scene graph, everything's a node arranged with layout panes. Threading, keep heavy work off the FX thread. Use task service. UI updates via platform dot run later. Styling, prefer CSS for consistent and maintainable looks. So keep this in mind. It will be it will feel more straightforward if you keep these in mind. So first topic is introduction to GUIs with JavaFX. So let's get started with JavaFX, the modern way to build GUIs in Java. So if you have worked with Swing before, in previous chapter, you'll notice this feels smoother, cleaner, and way more flexible. So let's start with the startup flow, because every JavaFX app starts the same way. You extend the application class and the JavaFX runtime calls your start, um, with the stage, the primary stage. So the start method. So inside that start method, you build your UI. You create your components, wrap them in a scene, and then place the scene on the stage. And finally, you call the primary stage dot show to make it visible. Uh, so you can think of it like this: the stage is your window, the outer frame. The scene is what's inside that window, and the nodes are all the controls components you add, like labels, buttons, text fields. So everything in JavaFX, even containers, is a node. So let's talk about building blocks. So the most common controls, you'll start with our label, which is to display text. You have a button for actions and text field for user input. So to organize them, we use layout panes. JavaFX has several of these. VBox, which arranges things vertically, top to bottom. Hbox arranges them horizontally, left to right. And border pane, which lets you position things at the top, bottom, left, right, or center. So you don't manually position elements with X and Y coordinates. The layout panes do that for you automatically. Like for example, suppose you have a label that says hello Java FX, and a button that says click me, and you add an event handler so that when the button is clicked, the label text changes, maybe to something like you click the button. And in JavaFX, this is super simple using lambda expression. Instead of creating a separate listener class, you can just write something like button dot set on action uh, e label dot set text, like you click the button. Yeah, that's it. It's one line, no clutter. uh, Now styling. So one of the best parts of JavaFX is that you can style your interface with CSS. just like a web page. You can set an ID or a class or any on any node, and then load a style sheet. For example, you might give your label an ID like title label, and then in the CSS file make it bold, larger, and or add padding, like something like this. uh, Title label FX font size 18 x padding 10. So yeah, this is a simple CSS code. So you can also add quick inline styles right in the code, like label. In the code you can write like this: label dot set style just gonna paste this. Let's say 16. So yeah, this is an inline styles right in the code. So let's picture a simple app. A VBox, containing a label and a button, and at launch the label says hello JavaFX, and when you click the button it changes to button clicked. That's your first working JavaFX GUI, which is clean, short, and easy to expand later. So some of the things to keep in mind, avoid, is if you forget to put your controls inside a container, nothing will show up. Every control must live inside a layout pane before you attach it to the scene. And don't do heavy work inside the start method or inside your buttons action. Remember, the UI runs on the JavaFX application thread. If you block it, your window will freeze, and so keep heavy work elsewhere, or use a background task. So yeah, so build, add, style, and interact. So that's a simple way to keep it. So that's about the intro. Next topic is GridPane layout. So let's talk about one of the most flexible layout tools in JavaFX, which is GridPane. So if you have ever built a form, something like name, email fields lined up nicely with a submit button below, that's exactly what GridPane is made for. It's basically a table-like layout where you position components by row and column. So why GridPane? Think of it as a spreadsheet for UI design. You decide how many columns and rows your layout needs, and then you drop each control, a label, a text field, a button into a specific cell. This gives you precise alignment and spacing control that's perfect for forms. So if you only need a simple vertical or horizontal stack, use VBox or HBox. So but when you need things to line up in a grid, labels on the left, inputs on the right, and GridPane is the tool. So you'll use a few key knobs to make it look right. We have add, node, column, row. We have column, space, but yeah. So it puts a control in a specific grid cell. You can also add these two if something should stretch across multiple cells. We have set h gap, v gap. These add space between rows and columns. We have set padding, which adds space around the edges so things aren't crammed against the window. These three alone fix most crammed layouts. For more fine tuning, you can use column constraints, row constraints. These let you control percent widths, alignment, and how components grow when window resizes. For example, you can set the second column, the text field column, to grow and fill available space, while the first column stays narrow. You can also set hgrow, bgrow to priority dot always, so components like text fields eventually expand naturally. So, and if you need alignment control inside a cell, use GridPane dot set h alignment or set v alignment to align items left, right, center, or bottom. So let's see an example, a simple form example, like we have a row 0 with a name label in column 0 and the text field in column 1, and the field stretched across the rows, and the row 1 which has a email label in column 0 and another text field in column 1, and row 2 which is a spacer cell in column 0 to keep alignment, and a submit button in column 1 aligned to the right. So once you add horizontal gaps, padding, growth rules, it looks clean and professional, but that's just a simple example. So a few mistakes to avoid: forgetting to set growth or width constraints. Without that, your text fields won't stretch when window resizes. They'll just stay small and awkward. And skipping padding or gaps that makes the UI feel crammed or unpolished. Always give it some breathing room. Misplacing column or row indices. If a component shows up in the wrong spot, double check your add coordinates. Remember, counting starts at 0. Yeah, that's about GridPane. So next topic is input and event handlers. So let's talk what actually makes JavaFX app interactive, which are events and event handlers. Up to now, we discussed about building UIs that displays controls, but they don't do anything yet. The whole point of event handling is to make your program respond when the user types, clicks, or triggers an action. So in JavaFX, every interactive control can fire events, buttons, text fields, even labels, paints. So you attach a listener using methods like set on action for buttons or text fields, usually when enter is pressed, set on key pressed for keyboard events, set on mouse clicked for mouse clicks. And the clean modern way to handle these is the lambda expressions. So instead of writing a long anonymous class, you just say something like button dot set on action let's say handle add yeah, and your handle add method does the work. So it's short and readable, keeps logic separate from the UI. Yeah, and so next is we have validation and feedback. So whenever you take user input, always validate it. Don't assume the user typed something valid. For example, if you have a text field, for adding a name. Check that it's not empty before adding it to the list. If it's empty, give feedback using a alert dialog. Like FX, JavaFX makes that easy. You can pop up an info warning or error dialog. For example, like please enter name before adding. It's simple, but make sure app look feel professional and user friendly. And next is buildings and bindings and properties. So let's step it up a little. Every control in Java has properties like text property, disable property. So you can bind these so they automatically react to each other. So here's a super common pattern. Disable a button that when a text field is empty, and instead of writing an if statement every time the text changes, you can bind them once. Button dot disable property dot bind text field dot text property dot is empty and close it. Now whenever the text field is blank, the button automatically disables. No extra code is needed. This is the start of what JavaFX what makes JavaFX powerful, which is reactive bindings and background work. So if your event handler needs to do something slow, like read a file or fetch data, don't do it directly in the handler. Remember, all UI work runs on the JavaFX application thread. If you block it, your window will freeze. So instead, use a task for background work. You can run the heavy task on another thread and then safely update the UI using platform.run later, or a property binding like message property. So remember, fast stuff like updating labels can happen on the FX thread. Slow stuff like file readings need to go off thread. Let's picture a small example and add to list app. So you have text field for typing a name, a button labeled add, and a list view string showing all names. The user types a name. If it's not empty, clicking add appends it to the list and clears the text field. If it's empty, shows an alert that says please enter a name. Bonus thing you could add is user binding, so the add button automatically disables when a text field is blank, and the data behind the list is stored in a observable list, which automatically updates the list view. That means the view and data stays in sync. You don't manually refresh it. So some of the common mistakes is updating the UI from a background thread. Always use platform.run later if you need to touch the UI after running code in a task, and cramping all logic inside the event handler. Keep your handlers short. Call helper methods for real work, and forgetting to keep the observable list as a single source of truth. Don't build a separate list and manually update the list view. Just modify the observable list. It will automatically reflect changes in the UI. So those are the common mistakes. So once you have got everything down, you'll start to see what makes JavaFX feel alive. Clean event handling, smooth feedback, and UIs that just work the way users expect. So the last topic is basic graphics with JavaFX. So let's wrap up our JavaFX module by discussing some fun drawing and animating things on the screen. So JavaFX gives two main ways to work with graphics, shape nodes and canvas. So shape nodes are the easy route. Shape nodes are like any other JavaFX controls. They are actual objects in the scene graph. You can add them directly to a pane, move them around, change their colors, and JavaFX handles redrawing automatically. For example, if you create a circle, give it a center position and radius, and add it to a pane, it just appears. You can then move it to updating its x and y coordinates, and because it's part of the scene, UI updates automatically. You can do this with shapes like rectangle, line, or text. All of them are nodes, just like buttons or labels. This approach is perfect when you want few visual elements that move or respond to user actions. And then we have canvas. So the second option is using canvas. So canvas is more like a traditional drawing surface. You get a graphics content and you tell it what to draw, like lines, arcs, images, shapes, etc. So the canvas doesn't manage nodes for you. Instead, you draw everything yourself in code. This gives you more control and better performance for lots of shapes or pixel based graphics, like drawing a game frame or a chart. But the key difference is, if you draw something once on canvas, it stays there. It doesn't automatically update when the window resizes or the scene refreshes. If you animate or redraw, you'll need to clear the canvas and repaint on every frame. And we have some animation options. So let's talk about animation and how we actually makes things move. So you have two main tools in JavaFX, timeline and keyframe. So this is great for smooth time based animations. You can specify how properties change over time, and JavaFX interpolates between them. And we have animation timer. So this gives us a per frame callback, sort of like a game loop. You get roughly 60 times per second. You can update your object manually, and you can so if you're doing something simple like bouncing a ball, or animation timer is straightforward. You just change the ball's x and y positions a few pixels each frame and reverse direction when it hits the pane's edges. So for example, you got a simple small window with a pane and a circle, and for a ball, when you hit start, the animation timer begins updating every frame, moving the ball diagonally. When it hits an edge, it bounces back by flipping the direction. You can add start and stop buttons to control it. It's great to start with, to understand how graphics and events work together. There's another thing, coordinates and resizing. So in graphics, coordinate starts at the top left corner, 0, 0. That's top left corner. So x increases to the right and y increases downward. If you want to keep graphics responsive, pay attention to pane size. It can resize with the window. So to keep things clean, either set a fixed drawing area or handle resizing by recalculating boundaries. If you use a canvas, you'll need to redraw everything when the window size changes. A few things to avoid when working with JavaFX graphics is doing heavy math in every frame. So keep your update code simple. A few calculations per frame is fine. Don't load data or do physics simulations directly on the FX thread. and forgetting to stop your animation timer, so when the window closes it keeps running in the background otherwise. And drawing once on a canvas and expecting it to lay out automatically. Remember, the canvas won't move or resize for you. It's if your windows changes, you have to redraw. Mixing layout managers and that resize your drawing pane unexpectedly. If your shapes suddenly jump around, check if the layout is resizing your pane. So that's about this JavaFX topic. It's a small topic, but it makes a lot of difference with your GUIs.